In the previous video session, we learned about the formula to find out the n term in an AP series. We also learned about what is an AP series. So in this video, we are going to solve some sums regarding arithmetic progression. So this is the first sum in which we are going to find out what is the 20th term in the progression. So let's first decide whether this is an AP or not. So for it to be an AP, we know that the common difference between the two consecutive terms should be the same for all the numbers in that series. So let's check out. If I take minus 5 minus of minus 12, I get minus minus plus, so 12 minus 5 is 7. Okay, so let's try it one more time. 2 minus of minus 5, and I get plus 7 again. So yeah, and you can see 9 minus 2 is again 7. So we have an AP series with a common difference of D to be equal to 7. The first term is A minus 12, and the question says that you want to find out the 20th term in the progression. So my n is equal to 20. So let's use the formula that we learned in the previous video. It says the nth term that you want to evaluate is equal to A plus n minus 1 times of D. So I guess we know what is the value of n. We also know the value of D, and we also know the value of A. A is the first term, and in this series it is minus 12. N is the 20th term that you want to find out, minus 1, and into D that is 7. And if I just find out the value of Tn from here, it turns out to be 19 into 7 minus 12 plus 19 into 7. And let's see what this value comes out to be. So we know 19 into 7 as 133. So plus 133. So 133 minus 12, 3 minus 2, 1, 3. Okay, this is 1, 2, and this is 121. Correct. So my 20th term here, n turns out to be 20th term is 121 in the series. So the answer for this question is 121. So the next question is, how many 3-digit numbers are divisible by 7? Okay, so let's first find out what is the first 3-digit number which is completely divisible by 7. That will comprise comprise the value of A. So what is the value of A? So let's check out. If I divide 101 by 7, no. If I divide 102 by 7, 7 ones are 7, you get 3 and 2, 7 fours are 28, still not completely divisible by 7. Similarly, I'll check out for 103. Similarly, I'll check out for 104. Similarly, again for 105. Now, 105 I divide by 7, my quotient turns out to be 15, and the remainder turns out to be 0. Yep. So this is the first 3-digit number which is completely divisible by 7. So A value, the first term of the series, should be 105. Now we need to find out which is the 3-digit number, the maximum 3-digit number which can be divisible by 7. So let's go in the reverse order. I'll first check for 999. So if I take 999, 7 if I divide it, then 7 ones are 7, 29, 7 fours are 28, 1 and 9, 7 twos are 14. So not completely divisible by 7. So we have a remainder in 999. Similarly, I'll check for 998, 997, 996, and so on till I get 994. If you check out for 994, 7 ones are 7, 29, 7 fours are 28, remainder is 1 and 4, so 7 twos are 14, remainder is 0. So when you divide 994 by 7, you get quotient as 142 and remainder as 0. So yes, this is the maximum 3-digit number which can be completely be divisible by 7. So here t nth term will be 994. Here you want to evaluate what is the value of n. Okay, so how many 3-digit numbers? That means you want to evaluate what is the value of n. Now, if they ought to be completely divisible by 7, that means the common difference between these two numbers should be 7. Okay, so let's use the formula again. Tn will be equal to a plus n minus 1 times of d. We know the Tn term as 994. The value of a is 105 plus n we don't know, which we want to find out, and the common difference is 7. Now you just have to solve this equation. So I'll just take 994 minus 105. So 994 minus 105, I'll do this. 7n minus 7. This turns out to be 889 plus 7, that is equal to 7n. So we get, so 90 plus 6, you get 896 equal to 7n. So let's find out n to be equal to, n is 896 divided by 7, which will turn out to be 7 ones are 7, remainder is 1 and 9, 7 twos are 14, remainder is 5 and 6 you carry forward, then you get 7 eights are 56. So the answer is 128. So what does this imply? It implies that there are 128 three-digit numbers which are divisible by 7, which are divisible by 7. So we can find out the n series. We can find out the Tn term as well as the number of terms as well using this equation. So let's proceed to the next question. So let's check out the next example. In an AP, the 17th term is more than its 10th term, and they're asking you to find out what is the common difference. So let's see 17th term. So they have said T 17th term is 7 more than its 10th term. So T10 is the 10th term in an AP, and if you add 7 to that 10th term, you get the 17th term. Since this both terms T17 and T10 comprise of the same AP, the value of A, that is the starting number of an AP, as well as the common difference for both these terms will remain the same. And this happens because they are a part of same arithmetic progression. They are the part of same AP. So we again use the formula for Tn term. So for 17 term, T17, I'll write this as A plus n minus 1 into D. If I substitute the value of n, I get A plus 17 minus 1 times of D. This is for the 17th term. So I'll say this is equation number 1. Similarly, the 10th term, T10 will be equal to, again I'll use the same formula. And if I use the same formula, I get A plus 10 minus 1 times of D. This is the second equation. Okay. And the relationship that we have between the 17th and the 10th term is given by this equation A. So I'll use this equation A and 1 and 2 together. So using equation A and 1 as well as equation 2, what do we get? So let's see. I'll substitute. So I get A plus 16D. This is my 17th term, will be equal to A plus 10 minus 1, that is 9D. This is my 10th term, plus 7. So this is my 10th term, this is my 17th term. And if I just scroll down and make some space for myself, then what do I get? So this A and this A gets cancelled off. 16D minus 9D comes out to be 7D, will be equal to 7, and that implies the common difference is 1. Simple. Okay, so we evaluated in the first sum how to find out the Tnth value. Then in the next sum we evaluated how many terms are present, that is n, and in this sum we evaluated what is the common difference. So let's proceed to the next example. So let's look at another example. In this question they are saying the sum of the fourth and the eighth terms of an AP is 24. So T4 plus T8 is 24, and the sum of the sixth and the 10th term is 44, and they are asking you to evaluate the first three terms of this arithmetic progression. In order to evaluate any terms of an arithmetic progression, we require three parameters, and those three parameters are A, N, and D. So we will use the equation to find out the n term for this T4 term and T8 term. So T4, using the equation, I get A plus n minus 1 D. N here will be 4. So 4 minus 1 will be 3, and it will be 3 times of D. Then T8 will be A plus 7D. And if I add them together, I get T4 plus T8 as 24. In other words, A plus A will be 2A, 3D plus 7D will be 10D, will be equal to 24. Now I will divide by 2 on the left hand side as well as on the RHS, and what we get here is A plus 5D will be equal to 12. I can simplify this and write as A will be equal to 12 minus 5D. Alright, so I'll name this equation as equation 1. Now let's try to evaluate the second condition. It says T6 plus T10 is actually 44. I'll follow the same process that we followed here to evaluate T4 and T8, and I'll write here directly as T6 will be equal to A plus 5D, T10 will be equal to A plus 9D, and adding T6 plus T10 gives us 2a plus 14d. And this equation 2a plus 14d will be equal to 44. Now again I will divide 2 on both the side, and after simplification I get this equation, a plus 7d equal to 22. Now we already know the value of a in terms of d from equation 1. I'll substitute this equation a in this equation and I get 12 minus 5d plus 7d as it is will be equal to 22. So plus 7d minus 5d gives you 2d. So I get 12 plus 2d will be equal to 22. And if I just, rearrange these terms, 22 minus 12 gives you 10. And d will turn out to be 5. So 22 minus 12, if you take 12 on the right hand side, turns out to be 10. And if you divide 10 by 2, you get common difference as 5. Fantastic. So we found out the value of d. Now using this value of d, I'll substitute d in equation 1. So I get a to be equal to 12 minus 5 times of d, that is 5 into 5 is 25, and 12 minus 25 is minus 13. So this is my value of a. So I know the value of a now. I know the value of d as well, and using both these equations and both these values, I can find out the second and well as the third term. So first term I found out was minus 13. So the second term a2 will be equal to minus 13 plus 5. This will turn out to be minus 8. And similarly the third term, this should be my a3, will be equal to minus 8 plus 5 will turn out to be minus 3. So the three first terms of an AP are minus 13, minus 8 and minus 3. This is it from my side. If you want to learn more, subscribe to my channel Just Learn. Hit like button if you like the video and the bell icon if you want to get notified whenever I upload a new video. Thank you. See you in the next video. Bye bye.